potential and standard potential. So the good electrocatalyst means it must lower the over potential, or in other term, it must possesses very low over potential. But it has some limitations. That is, its stability is very poor and its reaction rate is hindered by means of applied potential and standard potential. And due to its poor stability and multi-electron transfer, its reaction rate has been reduced. That is sluggish kinetic reaction. For example, ORR. As previously, Dr. Gautaman told that ORR is sluggish kinetics, which also hindered the efficiency of an electrocatalyst towards water splitting. So we need to fabricate an electrocatalyst which possesses low over potential and high stability with less entrance from the side reactions. The third one is on the Tafel slope. Not only the electrocatalyst must possess low over potential, but also it must have low Tafel slope value. So what kind of information we can get from the Tafel slope means we can able to determine the reaction mechanisms and how much of current has been exchanged between the electrodes. Through this, we can able to determine the catalytic activity of an electrocatalyst. So how we can determine this Tafel slope? By means of polarization curves. This is an example of a polarization curve which consists of many regions, but which point will be suitable for the Tafel slope measurement means the kinetically controlled region, that is the slow rate step, that is the rate determining step points are considered as an kinetically controlled region, which are chosen for the evaluation of Tafel slope using the Tafel equation, which is eta equal to a plus b log j. Eta is the over potential, a is the intercept, and b is the Tafel slope, and j is the exchange current density. If you extrapolated in the kinetically controlled region of anodic Tafel region, you can able to determine the OER reaction mechanism. Whereas if you extrapolated on the cathodic Tafel region, you can able to determine the HER reaction mechanism. So the good electrocatalyst means it must produce enormous amount of hydrogen, and also it must be used for the transport as well as the storage capacity with low over potential and low Tafel slope. Next one is how to fabricate these electrocatalysts. There are various strategies are available to fabricate the electrocatalyst. Among these, laser surface engineering finds extensive application due to its flexibility, scalability, and chemical-free protection, through which modifies the topography, chemistry, and wettability of the base